So hi guys, so we're going to be taking this question from the Woods and Raphael textbook. So it says, consider the two image subsets S1 and S2 shown in the figure for the set V equals 1. Determine whether these two subsets are four adjacent, eight adjacent, or M adjacent. So first we're going to start with four adjacent. So knowing that the set V is equals to 1, it means we cannot step on any point with 0. So to go from S1 to S2, we're just going to take the closest ones we see at the border, which is 0, 1, and 1, 0. It's S1 here and S2 here. So taking this as our start point, what move from S1 to S2, taking this as our start point, let's try and make a four adjacent move. Four adjacent move, we can only move in the north, south, east, and west direction. So we're going to try and move up. You can see 0, 0 is not in the set V, so therefore we cannot make this movement. Let's try and move from here to here. 0 is still also not in this set V, so we cannot make this movement. Therefore, we actually don't have a four adjacent move here at all. Next, let's move on to the 8 adjacent move. So in the 8th neighbor, you can actually make diagonal movements. So let's say, for instance, these are grid, and this is the center pixel X, Y. Diagonals are 1, 2, 3, 4. Then you can also make four movements: 1, 2, 3, 4. So that's 4 plus 4, 8. That's just called 8 adjacent. It uses all 8 neighbors of the pixel. So to make an 8 adjacent move, we can move diagonal straight, and 1 is in the set V, therefore we can make this move. So yes, it is possible to go from S1 to S2 using 8 adjacency move. Now M adjacency is a bit tricky. M adjacency actually allows all four neighbor moves. So all four neighbor moves are allowed as long as it obeys the set V. However, if you want to make a diagonal move, there's a rule. You have to ensure that the common four neighbors of the point 1 to point 2 that you want to move, you have to ensure that the common four neighbors are not in this set V. So let me show you that. Let's say we want to make a diagonal movement from this point 1 to this point 1. We have to check if their common four neighbors are in this set V. Four neighbor for 1 is 0 and 0. There are other neighbors here, 1 and 1, but we're not really interested in those. So 0 and 0. Now the four neighbor for this one is also 1, 0 and 0. And you can see clearly they share this neighbor. So therefore we now check if 0 is in the set V. If 0 is indeed in the set V, we wouldn't have been able to make this diagonal move. But you can see that 0 is not in the set V. Therefore, it's illegal for us to move from this point to this point. So therefore, you can make an M adjacent move in this question. Now the second question is develop to change something from eighth part to four part. So let's just understand how that will look. So normally this is how it will be. This is x plus 1, y minus 1. So let's make a straight diagonal move. By the way, this will be x plus 1, y. This will be x minus 1, y. This will be x, then y minus 1. And this will be x, then y plus 1. So first, we're going to locate all pixels that form an 8 connected path. So for example, maybe this may form a kind of diagonal path. So for this, we know that we don't want this to happen. Because this is a diagonal move, and a diagonal move not allowing the four path. So basically what we just have to do is we have to replace every single diagonal move we see with a valid four connected pair. So a diagonal can be replaced by a horizontal move, then a vertical move, or a vertical move, then horizontal move. It doesn't matter. So basically, we're going to first find the next intermediate pixel beside it, either horizontally or vertically. The next, we're going to make a horizontal movement. The next, we're going to make a vertical movement towards the goal. So basically, this is how we're going to be converting every diagonal movement into a four connected step. So you're going to do this for every single diagonal that you see. till you're done with it. So that's basically how the algorithm just works. It just finds every single pixel that is making a kind of diagonal movement and replaces it with a vertical to horizontal movement. That's just basically what the algorithm do. Thank you for listening. Any questions you have, do not hesitate to ask in the comment section. Thank you.